Hello, good morning, good afternoon, good evening, everyone, and welcome to our session about the water-climate nexus in mountainous regions. Mountains across the world are, of course, known as water towers, and many people in these mountains, but also downstream, depend on water coming from these mountains. However, climate change will probably affect um, the services these mountains provide, but hopefully also create some opportunities, and this we want to explore in this session. My name is Suzanne Jacobs, and I'm a postdoc at the Center for International Development and Environmental Research at the Justus Liebig University in Giessen, and I'm here with my colleague Björn Weeser. I will briefly describe the session before we start with the presentation. So our session is divided into two parts. First, we have six pitch talks, each 4 minutes long, where scientists share their latest research results. We do not have time for discussions, and therefore I encourage you to take note of the speakers' names and their contact details, so you can get in touch with them later on and discuss their work. But you can also contact us afterwards if you want to get in touch with one of the presenters and you didn't manage to catch the contact details. I would also like to draw your attention to two posters. We could not invite everyone for a talk, but these are very interesting to look at as well. So please find them in the poster booths number 6 and 22. Then the second half of our session will be a panel discussion. Here we will be joined by 4 experts in the field of climate change, hydrology, and water management. And we're very grateful that these people with a wealth of experience in science policy, but also in practice, were able to join us today. Any questions to our panelists can be posted in chat on the right-hand side of your screen. And with that, I would like to stop talking and give the word to Mr. Anup Malik. You have 4 minutes. Please go ahead.
Hi, this is Anup Malik. Good evening. I'm from Uttarakhand Forest Resources Management Project, Uttarakhand, India. My topic of presentation is exploring the intersection of water scarcity and socio-economic and livelihood factors in the Indian Himalayan state of Uttarakhand. Uttarakhand, a central Himalayan state, forms a unique system of water reservoirs sustaining life to millions living down in the plains. The state is extremely sensitive to climatic disasters. 85% of the state population lives in mountains. Water requirement of these people depend completely on natural springs, streams, and seepages, only to be replenished by rainfall and glaciers. The state forest department is implementing a Japanese-funded project, Uttarakhand Forest Resources Management Project, trying to address drivers of forest degradation by directly involving communities, called Van Panchayats. In English, we call them forest panchayats. These Van Panchayats are community-based institutions in the forestry sector. Almost 100 years old, these are one of the earliest examples anywhere in the world of formal decentralized resource management. The project is working with 750 of these Van Panchayats. The project constructed a real-time baseline survey in 687 of these Van Panchayats, covering 40,000 households. The survey was exhaustive, spread over a period of 3 years. The paper used this baseline data and some more data from secondary literature from water stress perspective and its interlinkages with forest management, socio-economic, and livelihood development. We used these findings and linkages to plan and implement project interventions to reduce water stress and improve the lives of common people. We understand that major causes of water stress in Uttarakhand are climate change, forest degradation, and development activities in disregard of ecological requirements. As a project, we do not have much control on addressing climate change and development activities, but forest degradation, we feel, is mainly because of deteriorating forest governance. By deteriorating forest governance, we mean erosion in community partnerships in forest management. Recurring forest fires are also mainly because of lack of ownership. Therefore, if we are able to qualitatively improve forest governance, where communities' participation uh, is getting enhanced, then it will show positive results in all for aspects of forest management. All this would mean reduced water stress. Uh, Now, in order to understand water stress livelihood migration continuum, we clustered all the project VPs as high, medium, and low stress clusters, obtained by applying K means clustering algorithm. The key variable here is available of drinking water in the villages that we surveyed. There is a high association between water stress level of participation in managing forests, fire incidences, and migration. And this becomes a cyclical effect. Lack of water also means less of productivity and increase in barren land. All these factors, they lead to migration from the villages that we surveyed. Migration is higher, as we see that migration is higher from high water stress villages. Uttarakhand Forest Resources Management Project, funded by Japan International Cooperation Agency, is addressing drivers of forest degradation by empowering communities and improving forest governance. The baseline data has helped the project in understanding the gaps better and maximize the impacts to reduce water stress. Project has generated during the implementation phase, project has generated about 1150 million liters of water harvesting, revived irrigation in around 100 hectares of farmland, benefiting about 1,000 households. We have also addressed eco-restoration works in about 30,000 hectares of community-owned forests. Project is also investing in improving farm and non-farm income generating activities and directly helping 15,000 women farmers in the state. All these interventions are improving governance at forest community interface. This will
Thank,
reduce incidences of forest fires and improve forest governance. All this will
thank you,
reduce water
Mr.
stress.
Malik.
Thank you.
Unfortunately, we have to switch to the next presentation, and I'd like Fabian to start his presentation.
Emerging water scarcity risks in Peruvian glacier-fed river basins, looks at hydrological risks, which are conceived at the intersection of human natural vulnerabilities and exposure to water scarcity. We here define water scarcity primarily related to reducing meltwater contribution in the Vilcanota-Urubamba Basin, which is situated in southern Peru in the central Andes. So we look here especially at a diverse set of vulnerabilities divided into 5 groups. You can see here population, agriculture, water infrastructure, natural resources, and water policies of the population, which is exposed to changes in meltwater contribution and other socioeconomic changes in order, finally, to support adaptation strategies on the long term. So to look a little bit in more detail into the methodology, we use a data set which has already been created in another study by Bautert et al. In 2017 on meltwater contribution. We look at water stress indicators, so we also include socioeconomic activities. And then we look at these 5 groups of vulnerabilities I already mentioned, so you can see a little bit more details here in the lower panel. So we look, for example, at age structures, water efficiency, livelihoods, the development, human development, inequalities, and water conflicts. On the agricultural side, we look at a little bit less variables, among others, crop diversity. For water infrastructure, we look at hydropower capacity and the diversification of energy sources. For natural systems, we look at the flow variation and water quality. And finally, we also look at policies. So in Peru, there's a new water resources law which creates subsequently water councils. So in this basin, there was recently a new water resources council established. So we take into consideration this water resource council with new policies for water management, conservation, a new law on the rewards mechanisms on ecosystem services, and also some updated laws on water and sanitation. Our study concludes that more than 1 million people could potentially be exposed to water scarcity in that basin. We especially see high vulnerabilities with rural-urban disparities. So the poorest, the most vulnerable are situated in the smaller settlements and the upward settlements, while people with lower but still medium level vulnerabilities are located in the cities, for example. So that means finally looking at the complete set, at the entire set of the components of risk I mentioned before, so vulnerabilities, exposure, and hazard, that the risk potential in the basin is quite differently. So, for example, in headwaters, although there are strong impacts from meltwater reductions, the overall risk might be not too high due to the low exposure and low population density. In turn, in the middle basin, where most settlements are situated, risk can be considerably higher. So this is a first study to show the need for a diverse set of adaptation measures. We particularly emphasize nature-based solutions and must look at good ways on how to include data scarcity and uncertainties. Thank you.
Great, thank you very much, Fabian. Then next up will be Ivan Lizarazo.
Everyone, it's my pleasure to talk to you about preliminary results on using remote sensing for gaining insight into wetland dynamics. Let me start highlighting the importance of paramos, which are ecosystems found only on the northern part of the Andes. In Colombia, paramos occupy 2% of the total country area, but produce 90% of total fresh water. Paramos face many threats, including mining, infrastructure projects, expansion of the agricultural frontier, and global change. Understanding paramo wetlands is crucial to take action to protect and conserve these water resources. To do this, remote sensing methods are necessary because field-based techniques are both expensive and labor-intensive. We are interested in devising a method for exploiting the huge archive of satellite data that is publicly available, in particular the Landslides optical images and the Sentinel-1 radar images. Our study area is the Sumapaz Cruz Verde Paramo in the Colombian Andes. Our reference dataset is a very accurate land cover classification obtained from visual interpretation of aerial photographs collected from 2010 to 2012. We focus on change detection of wetland vegetation productivity using the maximum Landsat-based normalized vegetation index in different time periods. In addition, we determine wetland water extent changes based on the statistical properties of the coefficient of variation in time series of Sentinel-1 images. I quickly describe our preliminary results. The two figures in this slide show the increase or decline of maximum vegetation productivity in the wetlands existing in the study area for two different epochs. Red color means productivity decline, yellow color stability, and green color productivity increase. In both figures, we highlighted some where significant decline happened. regarding vegetation. This detection of vegetation productivity anomalies could be used to define critical wetlands where further detailed analysis to establish driver or change could be taken. In our study, we found for every wetland estimation of water state change in the last 6 years. The figure here shows in red color the estimated load water for a single wetland. All in all, our result shows the potential of combining both optical and radar images data set to understand wetland dynamics. Apart from the change detection process explained in this talk, we have conducted wetland mapping experiments using machine learning and deep learning combined with cloud computing resources. This joint research effort between Universidad Nacional de Colombia and Universitat Giessen could further help to establishing early warning systems in páramos. Thank you very much for your attention.
Thank you also, Ivan. Then I would like to give the floor to Yari Barrero.
My name is Yadi Barrero. I am professor in Universidad de Antioquia in Medellin, Colombia. And I worked with the Professor Maldonado from Universidad de los Andes. Let me see. Okay, perfect. My work is about some elements related with use of water in agriculture in the different pattern to the adaptation to climatic risks in Colombian Andes. Agriculture is one of the most affected sectors by the variation of rainfall levels due to weather changing conditions. So the producers can react in a different way. And in our research, we want to explore how some features of the communities affect the water use. What did we do? We selected zones with very different conditions about infrastructure, market integration, type of territory, and a dissimilar quality of life level. We focus on analyzing the behavior of users during an experimental game. This was run in the Colombian mountains region near the capital city named Boyacá. And in the game, a group of 5 participants should select how many units of water extracted from an irrigation district over 2 different treatments to express the climate risk, low rainfall and extreme drought. That was named phase 1 and phase 2. What we find? All the farmers decide to increase the use of the irrigation district to replace the lack of rainfall. As this common district was a common pool resource, means that the high level of extraction was an expression of less cooperation. The second fact that we find was about that the 2 zones exhibit difference statistically significant in the use of water. These different patterns are expressed in 2 dimensions. First, the timing of adaptation, of reaction, because the zone 1, that is the drier zone, and the zone with lower condition, anticipate the extreme event using more water. That is the blue bars that is higher, you can see in the slide. The zone 2 put off the adaptation until the extreme event, that is the orange color bar. Now, the amount of extraction during normal rainfall regime was higher for zone 1, but this difference was not significant over the extreme drought. Why we consider that is this important? We think that this research shows the relevance of consider the heterogeneity associated with each region. That is very relevant to understand the reaction and to propose managing adaptation programs. Here you can see our email if you need more information or more details about this research. Thank you.
Thank you very much, Yadi. Then the next presenter is Joanna Orellana Alvear.
Hi, everyone. I am Joanna Orellana, a postdoctoral researcher in the University of Cuenca, working on the SDGnexus network project. Here, I would like to introduce you to my most recent work under my PhD thesis, named the Active Remote Sensing in the High Andes, New Alternatives of Exploiting Radar Rainfall Data for Water Management Applications by using a machine learning approach. We all know water is key for development. This is related to eco-hydrological services, the support on hydropower generation, and risk management, mainly floods. Here we can see a radar image of a very important flood event that occurred in my hometown, Cuenca, Ecuador, 2 years ago. The points are the rain gouges that we can see were out of the reach of this main cell of the storm. The satellite resolution as well, we can see that it's not able to capture the high variability of the rainfall event. So this in turn makes weather radar as a cost-effective solution that allow us to get a spatial resolution of rainfall information of about 100 to 500 meters. However, the use of this equipment is a little bit tricky because it only relies on records of reflectivity variable. This means that it needs to be converted into rainfall in order to be used. So for these very complex processes that involves a lot of correction steps and also the use of dense rain gauge networks for adjustment bias of these maps are needed. Also, very specialized techniques and knowledge is required to perform all this process. We developed the implementation of a radar network in the southern Andes of Ecuador. And here you can see one of the radars located in one of the highest summits. So in order to avoid all these complex processes for obtaining the rainfall estimations, we develop a strategy that makes the most of the native radar data in its original form in combination to artificial intelligence techniques, and it worked quite well. We were able to derive quantitative precipitation estimations from the radar data and also to model discharge forecasting that was used at the end for the support in decision-making to many applications such as water supply, water management, and risk management. So the main conclusions or the findings of our work was that we were able to prove that the implementation and rainfall monitoring with weather radar in mountain regions was feasible, in fact. And this allowed us to overcome limitations of rain gauge dependency in these regions. We consider also that this study was a step forward to analyze rainfall availability and patterns relevant for floods, droughts studies, risk management, and irrigation systems. And it sets the basis for the use of radar technology for addressing sustainable development goals. Will benefit strategies for water management, water supply, and risk management. I would love to get in contact with you. Here you have my contact details for further discussion. Thanks a lot.
Thank you, Anna. Then finally, our last presentation will be given by Alicia Correa. We cannot hear you right now.
Can you hear me now?
Yeah, perfect. Go
Great.
ahead.
Okay. So good morning, afternoon, and everyone in the different sites where you are. I am Alicia Correa from SDGnexus Network, Justus Liebig University, Giessen. In this opportunity, I will briefly like to show you what our network does, and then narrow in what the project we have now in the Pacific and in Amazon transects towards the water, energy, and food nexus adaptation to climate change. In the next slide, I would like to show a world map where it can be seen that the SDGnexus network is a global community of universities, research institutions and stakeholders promoting sustainable development. Coordinated from Germany, the network has core and collaborating partners in two strategically research regions, Latin America and Central Asia. Our goals are to establish a common research agenda to promote exchange and collaboration between academic institutions and extramural actors, and for the focus of capacity building to qualify the next generation of scientists as agents of change. In the following slide, I would like to present you a diagram that shows a transect, a altitudinal transect from the Andean mountains, in this case representing both the Pacific and the Amazon sides, to understand the interactions, synergies, and trade-offs between the water, energy, and food sectors in the transects. In the upper part, you will see some photos from these different sectors, and in the low part, you will see some potential affections for the climate and anthropogenic impacts. The Andean Mountains, as many times saying in this session as well, are very well known as water towers and ecosystem services providers for downstream users where hydropower generation and agricultural production take place. Following with this idea, I would like to take you now to our research area. So in this slide, I would like to, as an hydrologist and very much agreeing with the principle of integrated water resources management, to see that the water should be managed at the level of catchment, natural catchment areas. So for that, two catchments were selected for this study. One, Miram and Mataje catchment that drains into the Pacific Ocean, and Putumayo that drains to the Amazon side. Basic catchment information, as well as some discharge measurements, and a plot showing the variability in the altitude in this transit I show in the left panel. Data, a big question when you go into poor monitored regions. Spatial and temporal information are key for modeling and processes understanding. For that, some information we were able to collect. So in the central panel, you will see some precipitation, water availability, hydropower generation maps, some land covers, and so on. As well, in the left down panel, some discharge measurements used for calibration and also validation processes in the models. But beyond all this information, microscale data is essential for further constrain the models. And for that, some initiatives took place in the region, as you will see in the central low panel, some recent publication where the amount of water used for irrigation is presented in a small scale. So the next step is then to model a cascade model approach. So WEEP connected to LEAP, so water and energy models, connected via spot pi to calibration and results evaluation. These results at the end will drive us in a baseline in some scenarios to analyze the water, energy, and food between three main components: demand, supply, and resources and environment. With this, I would like to say thank you very much, and my contact details are there for further discussions.
Great, thank you very much, Alicia, and thanks again to all the speakers in our session. It's really unfortunate that we don't have more time to discuss each of your work in more detail. And once again, please get in touch with each other when you find interesting things you could collaborate on or questions you have, because it's really worth talking to these scientists about their work. So with this, I would like to end the first part of our session and continue with the second part, which is our panel discussion. And you see our panelists popping up on the screen one by one. Once again, please, if you have any questions to our panelists, put them in the chat on your right-hand side. They will be very keen to answer these questions. And let's first start with an introduction of our panelists. I would like to start. Our panelists, they come from a range of backgrounds, starting from science, going more into implementation and policy making or policy. So starting in the science, I will go to Wouter. You already checked, okay. So what role does the Water-Climate-Nexus play in your research?
Thank you very much, Susan. I hope you can all hear me. So Needs, I'm Wouter Buiten, Professor in Hydrology and Water Resources at Imperial College in London. And my main research interest is in understanding hydrological processes and how that knowledge can be used and be applied to support water resources management. And obviously, the nexus between water and climate is very important in that, because really climate are, if you will, the boundary conditions of the terrestrial water cycle. Any variability, any changes, any perturbation in the climate will ripple through, propagate through the hydrology and impact people that depend on water, that are at risk from water floods and droughts. And a particular interest that I've got is in participatory approaches to collect data and to turn those raw data into knowledge that can support decision making. And particularly, I think that's very important in mountain environments and in the context of climate change. I think that there's a consensus that we can't plan ahead for decades with managing water resources systems because of uncertainties in climate change and other boundary conditions. And so instead, it's necessary to really take a more adaptive approach, constantly monitor the system and make adjustments, change and adapt as we go. And obviously, monitoring data collection is very important in that context. As well as participatory approaches to co-create the actionable knowledge that we need to make proper decisions about how to manage mountain hydrology.
Great, thank you. I think we'll be talking about this later on in the discussion as well. Moving on, I would like to go to Santosh. Santosh, you work for the International Center for Integrated Mountain Development. And the center works on behalf of the people of the Hindu Kush Himalaya. How do the communities benefit from research and specifically in your field?
Okay, thank you, Suzanne. Hello, everyone. My name is Santosh Nepal, and I work with International Center for Integrated Mountain Development based in Kathmandu here in the Himalaya region. And we work for the Himalaya region, which actually the high altitude areas of this Himalaya region actually supports, the 1.9 billion people living in the mountains as well as the downstream river basin. So that's a huge, the support coming from the mountains in terms of water, food, energy, and other different kind of livelihood opportunities. And here, the climate change is actually impacting the water resources, ecosystems, and many different kind of services that the mountains are providing. That is actually creating, the imbalance in the different structures and functions. Not only climate change, but there are climatic risks, which are also posing risk to many different sectors. So our work is mainly concentrated on the, the impact of climate change and how it is affecting the water resources, water availability, and different water use in the downstream areas. And that's where we look at the, the upstream, downstream linkages and how these linkages will be affected by the climate change dynamics. So communities in the downstream areas actually depends a lot of things from the upstream areas. And I'll just conclude in the upstream areas. So any changes happening in the upstream areas will affect the downstream areas. That's where we want to, generate the coherence and then the collaborative opportunities between the upstream and downstream communities. Thank you.
Mm-hmm. Yes. Great, thank you very much. Marta, I can see you have some problems with the sound, right?
It comes on and off, so I hope you all can hear me okay.
We can hear you. I think Björn, is Ingrid around as well? Now I see Ingrid.
Yes,
Good.
yes, indeed.
Perfect. So we're moving a little bit from the science to the practice. Ingrid, you have a lot of practice across continents. What kind of project have you been part of, and do these differ between the regions that you've worked in?
Yes, indeed. I have been working for more than 20 years in different continents even. On the one hand, I worked more than 10 years in the Andes region in Ecuador. I also worked for several years in Kenya, in the water basin, Mau Mara. And actually, I'm working in the Comoros Islands in a water-related project ensuring climate-resilient water supply in the Comoros Islands. And so those regions geographically are quite different, but also really different according to water availability and the climate. So water availability, meaning with different precipitations, but also availability of the water. And obviously that leads to challenges which are quite different and solutions which you have to look at. And that requests quite some resilience from the people. Thank you.
Thank you very much. Then
You want some more
finally,
details on that?
we can talk about details later on.
Yeah.
Yes, thank you. Then finally, Marta.
Okay.
You're again from a completely different angle. You're more into financial instruments to protect natural resources. So can you tell us a little bit more about the approach you're using?
Well, basically, as most of you know, water is not well paid for. We don't even pay for the basic operation of irrigation systems, considering their importance in terms of water security and food safety, food security. So my work over the years has focused on finding ways to begin to value the true cost of water. And as you all know, water is not, cost is not, value is not the same as price. So we're in a process of basically ensuring that all users provide support for funding the different needs that water has. In my case, I have focused in terms of the needs of nature. And so it's a pleasure to be here and to hear the research from the perspective of several participants from Bogota, Medellin, Cuenca, all places that I know and work in, to figure out ways to protect the water sources. So over the years, there's been a few developments in terms of voluntary schemes like water funds that can begin to address this gap. And then also in terms of legislation, in the case of Peru, where now all water companies, drinking water companies, need to incorporate in their tariffs a percentage that goes to protect the water sources. So slowly but surely, we hope to get to the right price.
Yes, that sounds great. Thank you very much. And I noticed in a couple of the presentations, but also in some of your introductory talks, that there's a strong linkage between the upstream and the downstream communities. So do these communities deal with the same kind of impacts from climate change? Maybe Wouter, you could start. Do you have something to say about this?
Yeah, I think the short answer to your question is no. Obviously, the impact of climate change is highly variable depending on where you are in a catchment. I think there's been several presentations about the Andes, and I think the Andes are a great example of a mountain with tremendous gradients in water availability, and as a result of that, gradients in water security as well. And so there are many reasons why upstream and downstream people are affected in a different way, and especially that linkage between both. Very often the highlands are seen as the production area of water, and anything that local people do has an impact on downstream linkages. But at the same time, upstream people tend to be, or upstream regions tend to be more rural, tend to be poorer, so those people also have far less adaptive capacity. So I think it's a combination of both the physical access or the physical water availability, which tends to differ between upstream and downstream, as well as the broader social and economic capacity to adapt to any changes that might happen in the future. And that's, of course, in the broader context of dependencies, where one activity might have an impact much further downstream, which obviously makes things much more complicated.
Yes. I'd like to say to all the panelists, if you have something to add, then just raise your hand and I'll give you a word once someone's completed speaking. Then so please, Marta, I already saw you nodding when I asked the questions, so please go ahead.
Well, I think just to continue with what Wouter is saying, that the contradiction is that these people in the high areas are vital for the production of water, and yet we disregard them. It's the populations that are probably most ignored So there's an equity issue that I think is really important to recognize. It's usually older people, women, children. So the dynamics in terms of the social is really important to keep in mind. And then at the same time, they're probably the people that know the most about these ecosystems. They live them, they feel them. So I think that's really important to highlight. And in the Andes, we have the ancestral knowledge and technologies and understanding that most of the formal water management authorities have disregarded this understanding for many years. So the potential is huge to learn from those, and we have very limited time as climate change affects us.
Yes, that's definitely true. Santosh, could you add some experience from the Himalayas, maybe?
Yes, definitely. I actually agree with the remarks from both Wouter and Marta. My experience from the Himalaya region, there is a very strong, the upstream downstream linkages. What happens in the mountains actually affect the downstream, the communities, livelihood, and environment. We also need to look at the linkages that are more driven from the natural processes, like the in the context of mountains, the snow and glacier melt. And also we don't need to forget that there are anthropogenic drivers as well. The deforestation happening, or land use, land cover change happening, infrastructure happening in the upstream areas that also affect the quantity and quality of water and other resources available. So if you also look at from the perspective of the downstream communities, for example, the good watershed management, can provide a better quality and quantity of water resources in the downstream areas. But on contrary, if there is a bad management in the upstream areas, erosion, sedimentations, the landslide, that can bring more challenges in the downstream areas. So if you look at the communities, they are both like a challenge, deal with the challenges some time of the year, and then there's some opportunities some time of the year. So what we need to do is to, build that, the confusion to a cooperation modality in which the both upstream and downstream communities can live together, and then in a harmonious way. And then, like Martha already indicated, that there are, sometimes the mountain communities are disregarded for, the lack of opportunities, lack of resources in the upstream areas because of topography and other things. On contrary, on the downstream areas, there are more beneficial opportunities, water, nutrient, and other things. So how do we balance that? Probably a mechanism like payment of ecosystem services and other things. I think these are very important, and these are some of the experiences from the Himalaya region. And then I'll just touch upon the how the climate change is affecting these upstream downstream linkages, especially the meltwater, especially the extremes and floods that also need a very serious attention. And maybe we can address that in the next question.
Good. So maybe a question that's raised. So should we focus? Imagine we would want to develop a project. Should we focus on these communities living upstream, or should we take both of them into account, or where should we focus our work?
I believe you need both. You have to. We need a water basin approach, which unfortunately is complex and makes already a difficult situation even more complex. But I think climate change is highlighting the importance of a watershed approach. Because whatever you do, whether you only work in the bottom or you only work in the top, with a hydro project, whatever happens from the top is going to affect the management of your energy system. If you're working in the social sector, you need to think of the science. And it's that integrated approach that is so needed, and a systems approach. And unfortunately, there's no silver bullet. And I think spaces like the ones that we have today in this forum are vital to get the scientists to communicate the research so that we do make decisions based on evidence, which unfortunately with climate change, most people don't know what to do, and they just kind of go, okay, whatever. And we, you know, we understand that there's a lot of uncertainty, but decisions are being made, whether by omission or by bad decisions, right? But we need to make sure that we have that dialogue, continuous dialogue between the different audiences, the different sectors, that intersectionality approach, you know, and it becomes very complex for most decision makers, but we just have to at least hope to be making decisions based on evidence.
Yes. Yes, this sharing of scientific results is very important. Now, this whole thing of looking at a whole basin, this brings me to a question from the audience, saying climate change effects have a global effects. Does the sporadic mitigation measures over target project area will be effective for the? Well, the question is not completely finished. So if Santosh Sharma can finish the question, that would be great. But I mean, I think you can get the gist. If we put a project somewhere here, is it going to be effective somewhere else as well? Who would like to answer this question? Who would like to start? Wouter, go ahead.
Yeah, linking it actually to the previous discussion, very shortly, specifically on mitigation, and indeed climate change is a global phenomenon. So obviously a mitigation activity implemented in one place will be by definition global. So I think that's indeed a bit of the tragedy of the common atmosphere, that we can't really, in terms of mitigation, at least target our actions. At least it's different with adaptation. I think on the contrary is the opposite. Adaptation is by very definition is a very local process. I think here I fully agree with what Martha said about the need to take a basin scale approach and focus. But at the same time, resources are limited, and it's easy to say we need to work everywhere. Obviously, there's also a need to focus and see, well, where do we start? And I think in that sense, I'd like to draw attention to Fabian's presentation about try and identify who within a basin is most at risk, because that really should be the people that the policymakers and adaptation strategies should focus. But the problem is identifying who is really at risk in itself is very, very difficult, because as you probably know, the IPCC definition of risk being the combination of vulnerability, exposure, and hazard. And obviously those three aspects are very different dynamics and interact. So even identifying who is at risk, who should be the focus of adaptation and interventions is in itself challenging. And again, to finish with what Michael said, the more evidence reports, the better will be placed to try and do that exercise.
Well, Santosh, what would you like to add?
Yeah, the global climate change, you know, that the impact is across the countries, across the regions, whether it's mountains or plains. We from ICIMOR, we published the first Hindu Kush Himalaya assessment report in 2019. And the analysis from the different, you know, the scientific literatures indicate that the global temperature rise of 1.5 degrees Celsius will lead to a warming of, you know, the 2 degrees Celsius in the high mountain Asia. So that means that although we are talking about this 1.5 degree at the global level, that's already high in the context of mountains. Even in the optimistic scenarios, even if we are able to maintain 1.5 degrees centigrade, we are going to lose 1/3 of the glacier size, you know, the mass from the Himalaya regions. And then the pessimistic scenarios of, you know, the business as usual, 2/3 of the glaciers will be gone from the Himalayan regions. And look at the implications in the, you know, the downstream areas, the dependent sectors, agricultures. If you take an example of from Indus, 60% of water withdrawal in Indus downstream areas it's actually coming from the mountain water, melt water from the glaciers, ice, snow, and then the overall mountain waters. You know, that sort of dependency we can see at the downstream area. So it's definitely that we need to look at these global problems. We need to also look at the regional solutions. Solutions, that means that if you look at these river basins, one of the speakers have shown very nicely this upstream, downstream, you know, they don't limit within the nations. They are actually the across the nation. Sometimes 2, sometimes 3 nations. These river basins are shared. So in that context, I think we need a regional collaborations to work together to solve these problems. But at the same time, I would like to connect to the questions earlier, is that at which scale we want to work. That we need to actually look at the multi-scale, the approach, probably some kind of integrated river basin management framework, IRBM. There we need to look at the issues, which issues are relevant at which scales, and what sort of impact that can create in the larger context of the river basins. Thank you.
Thank you. This is something that should really be taken into account then. I noticed there's a very interesting question from Ivan. Ivan, can you ask the question yourself? You'll be given the permission to speak by Björn.
So in case it doesn't work, I can also work from the chat. So Ivan is asking about ancestral knowledge or scientific knowledge in high mountain ecosystems, which was addressed to Marta, but also I guess it's an interest of Wouter's work in Peru. I know you're doing this kind of things. So maybe both of you could address this shortly. Maybe Marta starting and then Wouter kicks in.
Yes, I think that we have a lot of recently published data, and I congratulate all of the presenters because I was so excited to see so much information from the Andes, and I really, the latest review of information regarding the Andean terraces is a document that we can reference. I'm looking for it to put it in the chat so that everybody can see it. But it's a recent meta-analysis to look at the andeneria or terracing in the Andes and all over the world to understand the hydrological contribution that they can make. So I think there's a lot of information that we can provide recently. Unfortunately, one of the conclusions of the study is that there is not enough scientific or peer-reviewed studies. There's a lot of great literature, but it's not peer-reviewed. So, I think that's a gap that we need to address. But in general, I do believe there's more and more evidence that I think tells the sort of formal engineering world to use more of the ancestral knowledge and information. So I think that's an exciting process. And I think it goes to the scaling issue, right? I think these are systems that are a right scale. And it's not a scientific term, it's my term, but it responds to the community's management scales. And the latest information, at least from Peru, where there's been a restoration of these systems, demonstrate that it also becomes a technology that is adaptable to people's daily way of living. It increased biodiversity in terms of the crops. It improves management. So it has all these co-benefits that makes us all think we need to go back to what our ancestors knew about and use them and complement them with these latest technologies like radars, like artificial intelligence and all these things that demonstrate that they're very effective. I mean, the sky is the limit in terms of what we can research about and learn from.
Yes. Thank you, Marta. Wouter, maybe you can give a short addition to that because our time is running out, and I also want to ask a question to Ingrid. Yeah. So please.
Very quickly. So indeed, we recently published a hydrological study of what you can call an ancestral artificial recharge scheme in Peru. And I think it's a good example of the kind of synergy in the sense that in all over mountain regions, not only in the Andes, but also in the Himalayas and others, there exist a lot of those local practices, often related to storing water, storing and harvesting water, as it's sometimes called, which in themselves are really valuable, but often the more formal water resources managers are a bit hesitant to include them into basin scale water management plans because of the lack of that hard scientific evidence. Obviously, we know that they work, otherwise people wouldn't have used them. But to integrate them in broader water plans, you need to have that scientific validation, if you will, and that's probably where science can come in to give that hard data that makes it easier to integrate local ancestral solutions within more formal, broader watershed management plans and systems.
Thank you, Wouter. Then Ingrid, my question for you. I mean, you're working more on the ground. You're more involved in the implementation of projects. What role does science play in this? Do you also say we miss some scientific evidence, or where are your project based on? Or yeah.
Well, if I may pick up what Marta was saying, no, like the knowledge of ancestral people, I think indeed farmers know a lot, and often scientists pick in on something they have seen of farmers. And indeed, you need to look for a balance in the sense things are going right that farmers do. Of course, they also do certain methods that they use which are not working. And it's a bit referring to what Wouter says. You need to try to scientifically be able to explain certain methods why they are working and why are they not working. So in my case, it is often to say it's a pity that on the ground, you know, there's so much going on of scientific work that you're not getting enough a return to use it in a practical way on the ground. Luckily, we can say during the last decennia, with the new technology that we have, articles or publicly available on websites. But even then, if you say an article is available, a farmer is not at that level. So it would be good if scientific results could be more implicated, spread out on the ground, because obviously it's from both sides. We can learn a lot of what we see on the ground from farmers, young farmers, older ones, all of them who are practically working. And on the other hand, we can learn so much from the scientific side, things that they through studies, through their work, that if we could use it and put it in practice, it would really help everybody, I think.
Thank you.
I don't know if that is
because
yeah.
It's definitely what I was looking for, the kind of information. I have to stop you here because we're running out of time. But I would like to ask each of you to give in one sentence. We talk about a lot of negative impacts of climate change, but what are the positive things we're seeing? So please give us one statement, starting maybe with Wouter. Would you be ready to give one positive statement?
Well, in the context of mountains, one aspect which you can consider positive is that global warming tends to make high altitudinal regions more inhabitable. And that is a risk, but at the same time also an opportunity to really find a way to make sure that we improve people's livelihood in those regions.
Great, thank you. Santosh.
Yeah, we need to understand the changes which are happening, and then also look at that if there is any opportunity. I can give an example of the hydropower, where there are climate projections which indicates that the probably more water will the more precipitation will happen, and then there is a seasonal variability. If we understand this variability well in advance, we can design the adaptation strategies accordingly to tap those opportunities, whatever there is. Maybe there are more risks, we don't know, but whatever the opportunities there may be, we will be able to tap that. Yeah.
Great, thank you. Ingrid.
I would say, if I have to say it short, due to the climate change, we have to become very flexible on the ground and especially very innovative, because we are confronted with a lot of challenges and problems, each time in different ways. And it's the resilience of the people, it has to be always more and more and really innovative to give an answer to all those challenges.
Yes, that's true. Marta,
I think
what
just
is your
to
positive?
reiterate that we are in a better position right now than ever in terms of finding solutions to these problems. We have the science, we have the entities, we have the rigor, we have the resources. But it's just a matter of making the right and urgent decisions based in evidence. And that's my call. All of us as researchers, as managers, we need to make decisions based on the evidence.
Good, great, thank you very much. So overall, I would say I think we could have talked at least an hour more.
Surely.
We will try to capture these challenges and opportunities and the current state of things. Perhaps in a research paper, we'll get in touch with you. In conclusion, I think what I can take home is there's this very important upstream downstream linkage between the communities up there, upstream and downstream, and that both of them should be taken into account when we're trying to address issues. We need skill dependent approaches, skill adapted approaches, but also we need to communicate our research and take into account what the local people already know. And I hope I summed up everything well by this. I thank again all the speakers and our panelists for participating in our session today. If you like, you can join for the next session, which is called Sessions Insight and Outlook at in 5 or 8 minutes, where we will summarize our session findings as well. And then I wish you an enjoyable rest of your day. Thank you.
Yeah, thank you very much.
Thank you, Suzanne. Thank you,
Thank
Björn,
you,
and thank you, everyone. Have a good day.
See you soon.
Great for
Bye-bye.
having us.
Bye, everybody.
Thank you. Thank you.